Good day, everyone. For today's lesson, let's start off with slope and y-intercept of a regression line. One important application of statistics is that it allows us to predict one variable from other variables. For example, you might want to predict the amount of income from the number of years spent studying. This can be done through regression analysis. Regression analysis mathematically describes the relationship between independent variables and a dependent variable. One type of regression is linear regression. Linear regression consists of finding a best fitting straight line on a scattered of plot of sample data. The slope and y-intercept of the regression line play an important role in analyzing a set of data. The slope indicates the steepness of a regression line, and the y-intercept indicates the location where it intersects the y-axis. The slope and the y-intercept define a linear relationship between two variables and can be used to estimate an average rate of change. So, for example, a teacher believes that excellence is a fruit of hard work and persistence. That's why she wants to prove if the number of students' absences is related to their general average. On her gathered data, the recorded number of absences and general average in the recent semester are shown on the table. So, the number of absences or X is 1, 2, 3, 5, 7, 9, 10. And the general average, or the y, is 98, 90, 86, 87, 85, 85, and 78. So the teacher decided to use linear equations to describe the relationship of two variables. She wants to see if two pairs of points will result in the same or approximately the same equations since the points came from similar set of data. For the two pairs of data, she used the absences and general average of students 1 and 7 and students 1 and 4, respectively. Her computations were as follows. So, step 1. Using the given data as points, find the slope or m using the algebraic method. So, use the points 1 and 98 and 10 and 78. So the formula would be m is equals to y sub 2 minus y sub 1 over x is x sub 2 minus x sub 1. And it would be like m is equals to 78 minus 98 over 10 minus 1. And they would subtract that and it would be m is equals to negative 20 over 9. And divide that and it would result into m is equals to negative 2.22. And he used the points 1 and 98 and 5 and 87. So the same process, m is equals to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So yes. Moving on, table 1, some branches of biology: botany, zoology, anatomy, taxonomy, cytology, and focuses on plants. Botany focuses plants, zoology, animals, anatomy, and so on. So, step 2. Find the y-intercept using the slope m. The point 1 and 98 and the slope intercept of a line y is equals mx plus b. So y is equals to mx plus b goes as follows. So 98 is equals to negative 2.22 times 1 plus b. So 98 is equals, so negative 2.22 times 1 will equal to negative 2.22. So 98 is equals negative 2.22 plus b, and then it would result into, you would move the 98 inside and it would result into b is equals to 98 plus 2.22, and you would add that and it would result into b is equals to 100.22. Same as the the right side. Next is step 3. Write the equation of the line, substitute the value of m and the value of b in y is equals to mx plus b. So y is equals to negative 2.22 plus 100.22. So you would add that and it would result to the answer. So unequal slopes and y-intercepts are solved because two different pairs of points are used. Since the slopes and y-intercept are unequal, two different equations are obtained using the algebraic method. Whenever there are more than 2 points of data, it is usually impossible to find one line that passes through all points. However, a best fit line that is a good approximation of the data can usually be found. This is best fit straight line used to predict the value of y for a given value of x is called the regression line. For statistics, there is a simpler way to find the equation of the best fit line. The equation of the best fit line is also called equation of the regression line or simply regression equation. So the equation of the regression line is that y is equals to bx plus a, where b is equals to the slope of the regression line and a is equals to y-intercept of the regression line. So examples, a is y is equals to x plus 3 and b is y is equals to x over 2 minus 1. b is equals to 2, a is equals to 3, the slope is 2 and y-intercept is 3. And b is equals to 1 half semicolon a is equals to -1, the slope is 1 half, and y-intercept is -1. As shown in the activity, the slope and y-intercept can be easily determined from the equation of a regression line. In real life, however, students need to calculate the slope and y-intercept from the raw data. The y-intercept and slope can be solved using the step-by-step solution and formulas for finding the slope and y-intercept. So the steps in calculating the slope and y-intercepts from a given set of data are the following. So step 1, make a data table with 4 columns. So the 4 columns are x, y, xy, and x squared. Note the sample size n. Step 2, list the data for x and y. Multiply x and y to get xy. Square x to get x squared. Complete the table. And then step 3, find the sum of x, y, or xy, and x squared by adding the values in each column. And then step 4, substitute the solved values into the corresponding formula. So the slope, or b, can be calculated using the following formula, as shown. And then the y-intercept, or a, can be calculated using the following formula, as shown. Let us solve the given situation, the previous activity. Step yes, step do, using these steps. By doing step 1 and 2, you will make this 4-column data table. So number of absence, x, general average, y, and then xy. xy because of said by the previous slide, you need to multiply the x and y to get the xy. So 1 times 98 is 98, 2 times 90 is 180, 3 times 86 is 258, 5 times 87 is 435, and so on. So you need to multiply the x to the y to get the xy. Yes. And you need to squared the x, the number of absence, square the x to get the x squared, which is 1 raised to the power of 2 is 1, and 2 raised to the power of 2 is 4, 3 raised to the power of 2 is 9, and so on. From the table of data, you will be able to determine the sum of x or y, xy, and x squared. These are the values that will substituted into the formula to calculate the slope and y-intercept. So n is equals to 7, 37, and so on. Now, the formula goes as follow, and the solution goes as follow, as it shows. And negative 1.47 is the slope. This is the slope, so it will be determined by the result of the equation. So from the previous activity, we obtained 2 equations of the line by using 2 different pairs of points. Using those steps, you will be able to determine the slope and y-intercept. Also, you will find the equation of the best fit line. This graph shows the number of absences, or x, and general average, y. The 2 computed lines in the previous activity are shown here. This also shows the best fit line obtained from calculating the slope and y-intercept. By simply looking at the graphs of the lines, you can see that only the line with best fit, that is the line with the equation of y is equals to negative 1.47 x plus 94.77. And I guess that's it for me today. I hope you learned something new about slope and y-intercept of a regression line. So thank you so much, and I'll see you next time.
Interpreting the calculated slope and y-intercept of the regression line. What is the interpreting the slope? The slope of line represents how the y-axis values change compared to the numbers on the x-axis. This is also called the rate of change. Positive slope equals y values are growing compared to the x values. Negative slope equals y values are decreasing, decaying compared to the x values. How to interpret slope? To interpret the slope of the line, identify the variables in the situation. Since slope is change in y divided by change in x, divide the y variable by the x variable to get the units for the slope. The larger the slope equals the steeper the line, or in the other words, the greater the rate of change. The smaller the slope equals the slower the growth or decay and slower the rate of change. The rate of change tells us how much change there is over the single units of measure. It can also help us forecast what will happen in the future. Here the example. The following table has the data for the height of a plant at different times. Note that the plant is already 40 mm tall when the data starts to be collected. Time in hours 0, 1, 3, 10. Height in mm 40, 78, 158, 420. Just looking at this data, it is hard to visualize what the data is telling us, but a graph can help us. In this case, the independent variable x-axis is time because time happens whether the plant grows or not. It is not dependent on the height of the plant. The y-axis is the dependent variable because the height of the plant depends on how long it has been grown. Simply looking at this data, it's hard to know what it means. Does it means the plant is growing quickly or not at all? A graph can help us visualize this. Here is the data on a graph. We can use the data and the graph to calculate the slope of the line. This slope tells us how much the plant grows on average each hour. In other words, the slope is the rate of change, or is this the case? The rate of growth. First, stair-step method. We see the growth of the line between x equals 0 and x equals 1 is the growth over 1 unit on the x-axis. We have the y values for these points from the data points, so we can use them to calculate the rise of these stair steps. Below is a portion of the graph. Zoom in between x equals 0 and x equals 1. It is important to note that the scale of the x-axis number is different than the scale of the y-axis numbers. This is why the amount of change in the x-axis direction is 1, the amount of change the direction is 38. This means the slope is 38. Number 2. Another method is to use the slope formula. Slope equals m, rise, run. Change in y values, change in x values. This information tells us that within 1 hour, the plant grows 38 mm. This is the slope. Since our line is a straight line, the slope for the rest of the line is the same. We can use this to answer some of the following types of questions, including forecasting what will happen in the future. We can use the slope to help us forecast the graph. The first way to do this is to extend the line out to the when x equals 24 to estimate the point. A more accurate way to forecast is to we add the rate of change for every additional hour needed up to 24 hours. In this case, our last height measurement was at 18 hours and was 724 mm. If the plant grows at the same rate for 6 more hours, it will grow. 6 times 38 equals 228 mm more. Thus, at the end of one day, 24 hours, it will be 724 plus 228 equals 952 mm tall. The plant we have been talking about this example is bamboo. It is one of the fastest growing plant in the world and can grow up to 912 mm a day, close to 3 feet per day. We can see this significant by comparing the rate of change of the bamboo plant to the rate of change of kudzu, another fast growing plant. The data for the kudzu are shown in this table. Here is a graph that shows the line for the growth of bamboo, blue line, and the line for kudzu, orange line. X-axis, time in hours, 0, 1, 3, 10, 18, 24. Height in mm of bamboo, 40, 78, 154, 420, 724, 952. Height in mm of kudzu, 40, 53, 79, 170, 274. In y-intercept, the y-intercept is the point where the graph intersects the y-axis, the graph. Any function that is of the form y equals fx, finding the intercepts is really important. There are two types of intercepts that a function can have. They are the x-intercepts and the y-intercepts. An intercept of a function is a point where the graph of the function cuts the axis. What is y-intercepts? The y-intercept of a graph is the point where the graph intersects the y-axis. We know that the x-coordinate of any point on the y-axis is 0. So the x-coordinate of a y-intercept is 0. Here is an example of an intercept. Consider the line y equals x plus 3. This graph meets the y-axis at the point 0, 3. Thus, 0, 3 is the y-intercepts of the line y equals x plus 3. Examples on y-intercepts. Number 1. Find the y-intercepts of the following function using the formula to find the y-intercepts. A. Y equals x squared minus 3 times plus 2. By equals x squared minus 1 x. Solution is using the y-intercept formula. To find the y-intercepts of a function, we just substitute x equals 0 in it and solve for y. Substitute x equals 0 and y equals x squared, and 3 times 3x plus 2 we get. Example of interpreting slope and y-intercept. 1. Suppose some doctors are conducting a study. They ask their patients how many servings of fruits or vegetables they consume per day. They also keep track of whether those patients are obese. They record the percentage of their patients who consume 5 or more servings of fruits and vegetables per day and the percentage of their patients who are obese. The data is shown in the graph below. Percent of adults getting 5 plus servings of fruits and vegetables ESVS. Percent age of adults that are obese. The equation of regression line is given to by equals negative 0.91 x plus 38.42. The slope is negative 0.91. The units of y are percent of adults and the units of x are also percent of adults. The unit of y and the units of x will cancel out when they are divided. Instead, to interpret the slope, state that the percentage of obese adults decreased by 0.91% for every 1%. increase in the number of adults who are getting 5 or more servings of fruits and vegetables.
To tackle about regression analysis, prediction, and estimation. If you possess the ability to predict what happens in the future, you will probably use the ability all the time. Well, you do not need psychic powers to make it predictions. Regression equations can be used to make predictions, as you already know. The field of statistics that deals with prediction is called regression analysis. Carl and Michael are both grade 11 students and are talking about their plans for the future. Carl starts to rethink about his plans of going to college. Is it true that spending more years in school will not increase the chance of getting a higher salary? Totally confused, he consults his advisor, Miss Jean, a statistics teacher, tells him about a study describing the relationship between years in school and salary. In the study, the regression equation was found to be y equals 30x plus 100, where y refers to the person's daily salary and x refers to the number of years the person spent studying in school. Getting the dependent variable y, just substitute the given value of x into equation y equals bx plus a. Let us look back at the situation in the previous activity. What might happen if Carl chooses to go to college? To help Carl decide if he is going to college, he can predict his daily salary based on regression equation by y equals 30x plus 100. How much is the possible salary if Carl takes a vacation course? If Carl decides to take a 2-year course, his time spent on studying will be 15 years. So x equals 15. So the solution for this is y equals 30x plus 100. Substitute 15 into x. So y equals 30, open parenthesis, 15, then close parenthesis, plus 100. Multiply 30 by 15 and you will get y equals 450 plus 100. So add these two, you will get y equals 550. So 550 pesos is the average daily salary Carl may earn. So what's more, based on another study, Carl found that the regression equation is y equals 40x plus 95, where y refers to the person's daily salary and x refers to the number of years of the person spent studying in school. How much is the possible salary if Carl finishes with an engineering degree? So this is the given or the solutions. So these are also the steps, as you can see. So first step, what is the regression equation? The answer is formula y equals bx plus 9. Then the equation is y equals 40x plus 95. How many years does it take to finish engineering? That's the second step. So our answer is going to be, according from George, 5 years. Step 3, what is the total number of years Carl spent studying? X equals 18, meaning 18 years. Number 4, substitute the answer in 3 into the regression equation of 1. So our answer is going to be y equals 40, open parenthesis, 17, close parenthesis, plus 95. So step 5, we will going to solve it. So 690 plus 95 is equals to 785. Then the last step is, what is the average daily salary Carl may receive? So the average salary Carl may receive if he finishes with an engineering degree is 785. So that is all for me. Thank you for listening.
Regression analysis problem solving. Regression analysis can be used in making estimations and predictions. Specifically, linear regression allow us to making predictions when a variable y is dependent on a second variable x. Based on the regression equation of a given set of data, this also holds true in life situations. One of the most common uses of regression is in college application and admission. Universities and colleges can use regression techniques to predict future academics, performance based on each student applicant's requirements. In this report, you will learn how to solve regression analysis problem based on real-life situations. To better prepare for solving regression analysis problem, let us first recall the regression equation, its slope and y-intercept. Also, practice predicting values of y-independent variable from x-independent variable by substituting x into regression equations. In the activity, recall linear regression considers specifically the slope, y-intercept, and dependent variable y, and dependent variable x, also your predictable y given for values of x. Before solve problems involving regression analysis, there are some things you need to know which can be done by following the how-to tips on the second slide. You should know how to identify the independent and dependent variables from a given situation. How to complete the statement logically. Blank depends upon blank. The first blank contains the dependent variable while the second blank contains the independent variable. You should know how to identify the slope and y-intercept from a regression equation. How to the number beside x is the slope and the constant number is the y-intercept. You should know how to calculate the slope and y-intercept from a set of given data. How to tips use these formulas. And you should know how to formulate a regression equation based on the slope and y-intercept. How to tips recall y equals bx plus a. You should know how to predict values of the independent variable from the independent variable. How to substitute x into a regression equation and solve. Before solving the regression equation being asked in the problem, you need to identify the independent variable x and dependent variable y. Blank depends upon the blank, which would be assigned as x. Math aptitude test or first periodical test, which would be assigned as y. Math aptitude test or first periodical test. The answer is statistic first periodical test depends upon the math aptitude test. Then prepare a table of values. This the table of values. Substitute the solved values to the formula for finding the slope and y-intercept of a regression equation. N equals 15. Here's the solution for solving for slope and for solving for y-intercept. Therefore, the regression equation is y equals 0.4949x plus 3.2. Ang answer day sa solving for slope 0.4949 and sa y-intercept is 3.198. Na-convert siya og 3.2. Mo na siya sa boss. Ang equation regression. Using the regression equation, we can predict scores in the statistics periodical test given the score in the math aptitude test. If a student gets score of 42 in the math aptitude test, then x equals 42. Ang solution ay y equals 0.4949 or 42 plus 3.2 equals 20.7858 plus 3.2 equals 23.99 equals na-convert siya sa 24. Mga siya ang answer. Therefore, if a student got a score of 42 in the math aptitude test, the student would expect a score of 24 in the first periodical test in statistics. You can now apply this procedure in solving for regression analysis problems anchored on real-life situations.